Hi everyone, this is Ashis. I teach math and science for middle school and high school students. Today in this lecture we'll understand about vector. But vector without coordinate system, it's very hard to understand, so I personally prefer that let's understand a bit about coordinate system first and then we can understand vector. And vector is widely used in physics, so let's understand it clearly. So what is coordinate system? We can represent any point in one-dimensional space. Think of 1, 2, 3 and etc. So this is, we always say 1D space, like one-dimensional flat space. A point can be represented anywhere in the line. It may go to 0, -1, a lot of things. Now when it comes to the plane, like where you can represent a pair of points, you can think of, you have x, you have y, and you have a pair of points x1, y1. Now that point can be represented into x and y coordinate system. And what was x1 here? So x1 is the distance on x-axis and y1 is your distance on the y. Now one of the important aspects here, like you might find out in multiple places, is about the distance of xy from origin. So this is nothing but the distance from the origin, and using the Pythagorean theorem we can easily calculate that d is nothing but square root of x1 square plus 1 square. Now when it comes to two different points, let's say I have, this is x coordinate, this is y coordinate, I have a point at here x1 y1, I have point here x2 y2, and we want to find out the distance between these 2 points. We can again utilize the same concept of the Pythagoreans. So what is the delta here? So the delta on this one is nothing but x2 minus, give me a second, x2 minus x1, and this one is y2 minus y1. So what will be the distance between these 2 points? Using the Pythagorean theorem, we can say y2 minus y1 square plus x2 minus x1 square. Great. Why it is important in our discussions, we'll see in actions when we talk about vectors. But now, I mean as we are discussing about the coordinate system, it is very much important to understand what is Pythagorean theorem at the end. So we can say that, I'll again go to the coordinate system and let's think about a point x1 y1 here. So if I draw a right triangle, so this is our right triangle where it is 90 degree and assume this is theta. If you have a right triangle, then this hypotenuse d will be square root of, this is nothing but the base and this is your height, so square root of base square plus height square. And we can easily prove it using area. So how to prove? So this is nothing but our Pythagorean theorem. We can easily prove it using a square. So you can think of, like, you have a square with length L, so you have a square with length L, and the L has been further broken down into 2 components, let's say A plus B. So it is broken down into 2 ratio. So I assume this is A and this is B. Again further it is A, B, this is A, this is B, and this is A and this is B. Okay, then we can connect all the dots and create a smaller square. Sorry, my bad. It is actually a smaller square, and you can think of that a smaller square arm is C. Everything is C right now. So now we can easily say that using the formula of area of a square, so LA squared is nothing but the area of the bigger square, and which is nothing but A plus B whole square, which is nothing but, you can think of like this entire square is actually part of one square, a smaller square called C square, and there are four triangles. Those are right triangle actually. So 4 multiple of triangle area. So what is the area of a triangle? It's half base into height. So what is your base of this particular triangle? You can clearly see the base is A and height is B. It's the same for all of them actually. Base is A, height is B. So A into B. If I just calculate, so that becomes 2AB. So you know A plus B whole square, which is nothing but the entire length. This entire length is A plus B. So it's nothing but A square plus 2AB plus B square, which is nothing but C square plus 2AB. You can cancel out 2AB, so that eventually becomes A square plus B square equals to C square. So you can clearly see that this is B, this is A, and this is C. So in a right triangle, it proves that base square plus height square equals to hypotenuse square. Okay, that's great. Now let's jump to the vector. So we talked about that how a point has been represented in 2D space. Now a vector is a quantity that has a direction associated with it. Okay. What is the difference between scalar and vector? So scalar is only a quantity. So scalar is only quantity. There is no direction associated with it. You can think of like 3. 3 is just number. You can say 3 meter or 3 kilogram or anything like that. So everything is scalar. But when you talk about vector, for example, let's say I'm just going with a velocity 5 kilometer per hour in north direction. So that represents me some quantity and certain directions. So that represents a vector. Now how I can represent this particular entity into the coordinate system, that we will discuss about it. So vector is nothing but a quantity with a certain directions. Yeah, let's talk about how we can represent a vector. So how we can represent a vector. So representation of a vector. So we can represent into two forms actually. So one way you can think of, like as I said, vector, it has a quantity and it has a direction, so it can be represented into the 2D space and 3D space, or you can think of n-dimensional space. For simplicity, we are thinking of a 2-dimensional space. So this is our x, this is our y. Let's think of, we have a point 2, 3. So you can think of 1, sorry, my bad, I can just take it. So 2, 3, here is 2, 1, 2, and 3. So the first representation, we can represent 2, 3 as a vector where it started from origin and then finished it exactly that point. So it has a head, it has a tail. You can think of an arrow. You can also represent in that way, like where we can say 2i plus 3j. So everything is representing the vector A. What is I here? I represents the directions. Maybe I represents, you can think of on the direction of x. So I represents on x direction. What is j here? J represents on y direction. Okay, so this is nothing but the vector, but the vector 2i and 3j, as I said, what it has two things. One is its value, or sometimes we call its magnitude, and it has direction. So what is the value of a here? How we can calculate the value? We always represents a magnitude with a bar. So the value of a is nothing but how far the point is from the origin. You can think in that direction. So we can easily apply Pythagorean theorems, because we know d is nothing but square root of 2a squared plus 3 squared, which is nothing but plus 9 is 13. So it comes around let's say approximately 3 point something, some value basically. Now that gives the real value, like the magnitude of that particular vector. What is the directions? So direction you can think of like, okay, it takes a theta degree from the x-axis. So the theta we can easily calculate using tangent. Now we'll go through all this concept in later, but you can think of like we can easily calculate theta using tan inverse your y by x. So that is nothing but 3 by 2. That comes some value, let's say it's bigger than 45 degrees. So some sort of your, let's say assume 50 degrees. Okay, so what is the directions here? We can say it is tan inverse 3 by 2, which is 56 degree from x axis to y axis anti-clockwise. Okay, so we are going from this to that. Okay, it's a positive 56 degree in the first quadrant. Now when it comes to the vector additions, so just now we saw that how we can represent a vector like in a two-dimensional space, like either you can represent like this way, or you can represent 2i plus 3j, like your the ith component representing your x directions and j component is representing on y directions. That is the way you can represent it. It should be very common for three-dimensional space, where a vector could be, say, represented in three-dimensional space. We will discuss more about three-dimensional space later, but it should be very similar, where you can think of like it can be represented as a1i plus b1j plus c1k in a three-dimensional space. Yeah. Now let's talk about vector additions. Why it is important? Because we need to understand here. So you can think of one of the real examples, real life examples, and then we can just understand the vector additions with respect to that one. So you can think of, let's say I have a river and the river is flowing in these directions, let's say x directions, and you are taking a boat to go from these particular positions to the other side of the river. So you started on that directions, but as river is flowing in that directions, instead of you landing here exactly to the opposite point, you actually landed to here. Why? Because your vector, like your direction was true north, but at the same time water was flowing on the x directions, like towards east, and then you are landing exactly here in this particular point. Now yes, so that is your resultant vector, that we will understand and calculate what is the resultant vector here. But you can clearly see your vector, if I just simply say v of u, like your velocity is impacting to the true north, and then we have a water vector, like water is flowing on that direction, so your resultant vector is these directions. So logically our vector is nothing but v plus w. Now let's go to the coordinate system and understand what is happening. So we can say that I have a two vector, vector A and vector B, and for time being we can say vector A equals to 2 comma 1 and vector B equals to, let's say, 3 comma 2. So how I can represent here 2 comma 1, so this is, you can think of, this is our 2 comma 1, so this is a vector. Now when it comes to the another vector, like you are applying another vector on top of the first one, the basic fundamental things we can always do, like where the places where the first vector ends, start the second vector. So you can think of, like, you can think of your imaginary reference point here. The origin could be here and you are starting B from there itself. So now B, what is the B value? It says like, okay, go to the 3 on the X and then top Y. So I'm just saying, okay, go to 1 2 3 here, and then let's say if I just assume in that way, go to top 2, so that could be your B. And then what is the resultant one? So the resultant one is coming from here to there, so this is your R vector. So what is the R vector here? How we can add it? It says like add all the component, like all the X component with your X component. So basically it says 2 plus 3, and what is your J component is nothing but the I direction component, right? So the overall becomes 5 comma 3. Correct. So that is your resultant vector. Now similar thing is happening when we are talking about this scenario where river was flowing in the X directions and you are traveling to the Y directions, and the resultant becomes R. So in this coordinate system, what is the magnitude of R here? It's again square root of 5a square plus 3 square, 25 plus 9, which is 34. So it's approximately close to 6 for time being. Now and what about the theta? So we can simply think of, like, theta is nothing but exactly same way. What was the value of Y axis? It is 3. So we can say theta is nothing but tan inverse 3 comma 5. So that was the resultant theta actually. Okay, that gives you the directions, like which directions the resultant vector is going. Now whenever it could be possible that there are multiple vectors is applying on top of that one. Let's say you have, I can just take another picture and I can say, okay, you may have A vector, B vector, C vector is applying on top of that one. You can think of like in our river examples, like you are traveling to that V directions, W was the water flow, there could be another flow, let's say Z, that was talking about wind. So all the three components is impacting on the result. So R could be that time V plus W plus C. Yeah, so Z could be the wind vector. So it could be very possible here, but the important part here, it does not matter the sequence. You can apply A first, then B, then C, or it could be A, then C, then B. It always give you the same result vector. Correct. So you can think of like, okay, my A vector will be this, and then B vector will be this, then C vector will be this, and that becomes my resultant vector. So resultant vector could be A plus B plus C, and you can apply any order, it does not matter, you'll always get the same resultant vector. Now in these examples, let's take some random value here. Let's say V is for time being 3, so okay, V is time being 0 comma 3. So this is nothing but, you can think of like, if I just simply think of xy coordinates, so this is x, this is y, so this is nothing but 0 comma 3. So this is our first vector, V vector, and then you can think of W is nothing but 1 comma 0. So yeah, 0 comma 3 and 1 comma 0. So this is nothing but, think of this is 1, so this is 1 comma 0. So what is our resultant vector here? So if I think ignore for time being, okay, wind vector, if I just ignore the wind vector here, then what is our r? R is nothing but 1 comma 3. So this point is actually 1 comma 3. And then what is the magnitude of r? So magnitude of r is nothing but square root of 1 squared plus 3 squared, which is 1 plus 3 equals to 1 plus 9. Sorry, my bad. 1 plus 9 equals to square root of 10, which is probably 3.1 or 3.2, something like that. So you can think of, like, even if your velocity, the velocity you started was actually 3 meter per second and wind velocity was actually 1 meter per second, but the resultant velocity is 3.1 meter per second. So you are moving faster because water is helping you. So the river was helping you to go to the other side of the river. But importantly, you see that you are not reaching exactly to the opposite point. You are, some extra theta has been impacting you. So what will be that theta here? So that theta will be, you can think of like this particular from this picture. So if I just take another one, so theta will be how much is this one versus this one. We can easily find out the tangent. So theta will be tan inverse of, this is 1 divided by 3. So tan inverse of 0.33 value, whatever the value it is. I think it could be close to 20 degree, 30 degree, something like that. Yeah, but that should be the value here. So we can think of like, okay, you changed from the true north to that particular degree to the east side, right? Okay, so till now, whatever the things we discussed, if I just go back to the top, we discussed about on the two-dimensional space how the point has been represented. We discussed about how the distance has been calculated in two-dimensional space. We did not discuss about the midpoint right now, but we discussed about Pythagorean theorem. We discussed about how to represent a vector in two-dimensional space, and we discussed about how the vector addition happens, and a real example scenario, the boat scenario. You are just crossing a river. Today we are just discussing about the two-dimensional space and the representations. In the next video we can represent about three-dimensional space and discuss more on the other vector examples. There are a few examples like where we can see that how the vector products will be applied, like dot product and cross product, but those things need some physics concept first to understand and then try to apply them. So we're just keeping them in the next video. If you like the video, please like it and subscribe it to our channel. And I just want to take a moment and then suggest you can go back to our Ashis Academy website, and in the forum you can see that what are the things we are doing in our regular classworks, and we generally give some sort of your assessments. You can go to that assessment and try out at your time frame. You can review what are the things we did on the classwork, like last classwork we did some of the very vectors and math things here. So you can just go back to the classwork sections and try out that what we learned in parallel. But yeah, I encourage you to go to the Ashis Academy and try to explore them. We'll be adding a lot more content in the website and we'll discuss there. And this is our student stories. So yeah, you will love that we are just trying to share our stories, what we learned into day-to-day basis, and we are happy to take your feedback in parallel. Yeah, please like us and subscribe us so that we can reach to multiple STEM based students and they can get benefit from us.